Myself, Lohit Muthamsetti, I would like to discuss about a connectivity cluster access method for networks and computations. Navigating to the complexities of spatial network databases. Before that, the authors are Sashi Shankar and Junril Liu. And the content is classified into introduction, problem, importance, challenges, limitations and novelty, contributions, validation, finally its conclusion. Introduction. Spatial network databases are integral to the infrastructure of numerous applications from urban planning, logistics to social networking and environmental management. These databases are pretty much handle the complexity of a spatial information where the connection between the data points are pivotal, necessitating efficient access and computation methods. This exploration delves into the groundbreaking approach of CCAM, which redefines the efficiency in the network computations by focusing on the connectivity rather than the proximity or profiling the performance of a special database to a new heights. And the real-time example would be the modern smart city applications. Spatial network databases are used to manage and analyze the transportation infrastructure, including road networks, public transit systems, and shared mobility services. CCM could help to improve the efficiency of an application like intelligent traffic management system and multimodal trip planning. Moving to the next slide, the problem. The problem addressed in the paper is the efficient support of network computation and aggregate queries on spatial networks. The author makes it clear that the issues such as limitations of existing spatial access methods and the need for efficient spatial network databases to support network analysis. Traditional access methods are designed with a proximity as priority, fall short in the network computation task which lacks of connectivity to take it precedence. Moreover, CCM emerges as a solution for remaining the access methods by clustering the data based on the connectivity, aiming to drastically reduce the cost of network operation supports complex queries with an unprecedented efficiency. As you can see in the picture, it again classified into different terminologies to get it done so that it makes even more complex to retrieve the data. The importance, the significant and relevant as it focuses on improving efficient network computations and queries, which are pretty much crucial in various fields such as transportation applications like intelligent vehicle highway systems such as IVHS and the advanced traveler information systems such as ATIS. And as you can see in the picture, these ATI databases are again explored in different fields such as highway-based sensors, traffic reports, roads, city maps, constructions, and the schedules and business directories. Moreover, in a car, default driving sensors. Moreover, personal communication devices such as smartphones, laptops, and any electronic devices. Adding to that, office, home shopping malls, and in the information systems, as referred in this picture. These spatial network in a graph which nodes and edges are embedded into a geometric space equipped with a certain matrix. These spatial network databases are integral to the infrastructure of numerous applications from urban planning and logistics, social networking, and many environmental managements. As you can go through a real-time example, in the logistics and supply chain domain, efficient spatial network databases are important for optimizing the transportation routes, deliveries, schedules, and resource allocation. CCM could help to improve the performance of an application like fleet management, inventory control, and last mile delivery. Moving to the challenges. As the authors suggest, the problem is computational complex. As the authors mentioned, the challenge associated with the design and the evaluation of a spatial access method for network computations. The large search space of spatial networks the difficulty of efficiently supporting network operations make this even more harder to solve the problems. And going to the limitations and the novelty, the author indicate that the problem has not been solved before in a satisfactory manner as they highlight the limitations of existing spatial access methods. The proposed CCAM access method is to appear on the novel approach that extends and improves upon the related work. The author demonstrates awareness of related data and previous work in the field of spatial networks, databases, and access the methods. The author identifies the limitations of related work such as inability to efficiently support and network computations aggregate the queries. The CCAM access methods is proposed to solve the limitations efficiently supporting network operation. The author do not explicitly critique any unreasonable assumptions in the related work. Moreover, the impact of removing an unreasonable assumptions are not yet discussed. The contributions The contributions of CCA access method to be appeared to an extension and improvement of the related work focusing on the efficient support of network computations and aggregate the queries. The problem of efficiently supporting network computation and queries on a spatial network seems to be a new challenge on this platform. The paper proposes the CCAM access method, including its clustering algorithm, data file structure, and procedures for implementing various operations. The paper provides the performance of CCAM with other access methods such as depth first search, AIM, and grid file. Coming to the validation, paper does not present a case study but rather focusing on the more of into analytical evaluation and pretty much majorly focused on the cost modeling of the CCAM access method. This paper does not use statistical hypothesis testing, which is a setback for this research. The paper provides an analytical evaluation of CCAM access method. The paper discusses more of computational complexity of a CCAM access method. The paper includes theorems and lemmas to support more of into the analytical evaluation, and adding to that, the paper does not present any experimental evaluation but rather focusing more into analytical cost modeling. The strength of methodology or the rigorous analytical evaluation of cost modeling, which allows for a detailed comparison of the CCM access method with all other approaches. The weakness is the lack of experimental evaluation. The author is likely to choose the methodology to focus on the theoretical analysis and to demonstrate the potential efficiency of a CCM access method through the cost-cutting modeling without the need of an extensive experimental validation. Going to the conclusion, overall, there is an example for the validation methodology. In environmental management, spatial network databases are used to model and analyze the flow of water, energy, or pollutant through the man-made systems such as CCAM could help to improve the efficiency of the applications that simulate and optimize the management of these complex environmental networks. And winding up with the conclusion, overall, the paper presents a novel approach to efficiently support network computations and aggregate queries on spatial networks with a focus on the CCM access method. The problem is clearly stated, and the author demonstrated the importance and challenges of this problem. The paper provides a detailed description of CCM access method and its analytical evaluation, highlighting its potential advantages over existing access methods. The lack of experimental evaluation is the main limitation or setback, but the analytical cost modeling provides a solid foundation for the proposed approach. Thank you.